A resting neuron, one that is not conducting signals, contains potential energy resulting from an electrical charge difference between the inside and the outside of its plasma membrane. The cytoplasm just inside the membrane is negative in charge, and the fluid just outside the membrane is positive. The membrane is said to be polarized. Like a flashlight battery, the difference in electrical charge carries potential energy, which can be measured as a voltage. The oscilloscope shows this charge difference, called the resting potential, in millivolts. A neuron has a resting potential of about minus 70 millivolts. What causes the resting potential? The plasma membrane of the neuron keeps large negatively charged molecules such as proteins inside the cell. Pumps and channels in the membrane regulate the flow of positively charged sodium and potassium ions. The cell maintains a higher concentration of sodium ions outside the neuron membrane than inside, and a higher concentration of potassium ions inside the cell than outside. Sodium channels allow very little sodium to diffuse into the cell, but potassium ions can flow freely out of the cell, adding to the positive charge outside. The sodium-potassium pump actively transports more sodium ions out of the cell than potassium ions into the cell, contributing to the buildup of positive charge outside while keeping the concentration of sodium low in the cell and the concentration of potassium high. The diffusion of positive potassium ions out of the cell, plus the large negatively charged molecules trapped inside the cell, cause the charge difference that constitutes the resting potential.